All right, we're going to go through these a little quicker than what we did yesterday. And we should be, in my last class I got through 11 through 20 with time to spare. So we should be able to do the same thing in here. So let's take a look at number 11. Now these kind of questions will be on the final, I promise you. Not every single one, not all 1 through 20, but there's definitely going to be a bunch of them. I would say maybe 5 to 10 questions from this test. They're going to be on the final exam. And so you want to make sure you know how to do all 20 of them. So just in case those problems are on there, you'll know what to do. All right? Yes, Blake.
There's 40 questions on the final.
That's correct. There's 40 questions on the final. All right, let's take a look at number 11. It will take me longer to draw this picture than it will to solve the problem. But you got to know stuff, okay? It's not hard to do. This is quick. Literally, you could do this problem in 5 seconds. Okay, that is no exaggeration. You should be able to do it. Would you agree, Joe?
Yeah.
In 5 seconds, you should be able to do this problem. That's all it should take. Because you have to know something about this, and then you can do this problem in 5 seconds. Let's take a look. This is what you have to know. Now, you don't have to write this stuff down on the test. I'm writing it down because we're reviewing the test. When you have a 45, 45, 90 triangle, the hypotenuse, put your hand down, please. The hypotenuse is equal to the square root of 2 times one of the legs. This is something that you have to know. You can't just show up and just expect to go 1 plus 1 equals 2 and get an answer. Right? It's not like that anymore. There are things that you have to memorize in order to see a relationship between things. If you know this, and you didn't really have to write it down, but you should know it. How do I find the hypotenuse? I take the leg and I multiply it by square root of 2. So here it goes. Ready? You count. That was less than 5 seconds. That's all I had to do. That's all I had to do. Okay? I didn't have to do any math. I didn't have to add anything. All I had to do was put a 16 next to a square root of 2, and that's the hypotenuse. That's all there is to it. Now, if I would have told you the hypotenuse, it would have been a little more than 5 seconds. Okay? It's a little bit more complicated. But I made this one as easy as I possibly could. I gave you the leg. All you had to do is multiply it by the square root of 2 to get the hypotenuse. It's not the square root of 32. Some people did that. You can't go 16 times 2. This is not a regular 2. It's under a square root. I can't multiply those two things together. Number 12 was just as easy. But again, you have to know some stuff. All right? You can't just show up and just not know these formulas and these relationships. You got to know that stuff. This is what this is all about. Number 12, they tell you this is 30 degrees. That's a right angle. So what's this angle up here going to be? It's going to be 60. Now, you didn't have to write it down there, but I'm just doing that for the sake of this problem. Look, 9 and x. Here we go. Now, there's two things, 30, 60, 90. I'm going to write down two things you should know. You didn't have to necessarily write this stuff down on the test, all right? If it helped you, maybe you could, but watch. On a 30, 60, 90, the hypotenuse is equal to twice the short leg. Well, how do I know which one the short leg is?
The one that's opposite the shortest angle.
Right, it's opposite the smallest angle. So 30 degrees is the smallest angle, so 9 is the short leg. What is x then? If this is the short leg, what is x? It's the long leg, and we have a relationship for that too. We know that, and this is something you have to know. You got to memorize it. The long leg is the square root of 3 times the short side, or the short leg. All right, so that's something that you have to know. Javon, you paying attention to this? All right, doesn't look like it. Let's focus. Put your attention on what I'm doing right here. So this is the relationship between those things. Now, watch this. This, you had to realize that was the short leg. This is the long leg. So what do we use? We use this one right there. They already know the short leg, so what is x? It's just 9 times the square root of 3. It's all there was to it. You don't have to do any arithmetic at all. You just put the 9 next to a square root of 3, because look, 9 is the short leg, right? You stick 9 times the square root of 3. That's what it is right there. That's how you write it. Some people wrote it like this, and I gave you credit for it, but when you're doing math, you always put the whole number out in front of the square root. Okay, it just looks better this way. I would have accepted this. That would have been fine, but it just looks better like this. If you want to look like you know what you're doing, you would write it like this. Okay, that's the only thing. And it says, write the answers as an exact answer and simplified. This is exact. if you would have taken this number and put it into a calculator and got a decimal out of it, that is not an exact answer. That's an approximation. Okay, it's not exact because this square root, this will come out to a decimal. It'll keep going, 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 going. That's not exact. This, what I've circled, is the exact answer. And we've discussed that before. I told you what the difference between an exact answer is and an approximation. And this is how I want you to write it. I think the day or two days even, the last 2 days we reviewed this stuff, I think I said when we do these 30, 60, 90, and 45, 45, 90, that I will expect an exact answer and no decimal. And that's sure enough, that's what I made you do on the test. Okay, let's do number 13. 13 was a little bit more difficult, okay? It was like a couple steps instead of just one step. So this definitely took a little more than 5 seconds like the first one did. But it'll just test to see if you really know what this stuff's all about. That's 60 degrees, that's 90 degrees, so this has to be 30 degrees. You didn't really have to put that in there, but we did. We got to solve for this. Now, look at the sides. Look to see what these sides are. Look at the x. Which side is the x? Is that the short, the long, what? It's the hypotenuse. It's the hypotenuse. It's opposite the right angle. What about the 7? It's opposite the 60, so it's the what? That's the long leg. Now look, do I have a relationship between the long leg and the hypotenuse? I don't. Remember this right here? I have a relationship between the hypotenuse and the short, and the long and the short, but I don't have any kind of relationship between these two. So what do you think I have to find then? The short side. That's right. It doesn't tell you have to find the short side. You had to figure that out on your own. All right? Some of these problems weren't just perfectly straightforward. Sometimes you had to think a little bit to find this x. So I can't go directly from this to this, but I can go from here to the short side. So if this is the short side, what do? If I know the long side, how do I get to the short side? I divide. That's right. I divide by the square root of 3. Let me just show you. Remember, I'll write this down again. The long side is the square root of 3 times the short side. So which one do we know? We know the long side, right? So put a 7 right there. Equals the square root of 3 times the short side. Don't know what that is. I just put the word short right there. How do I get short by itself? Divide by the square root of 3, just like Jake said earlier. Okay, that's the short side, 7 divided by the square root of 3. What are we trying to find? We're not just trying to find the short side. The question says find x. So what's the relationship between the short side and the hypotenuse? The hypotenuse is twice as big as the short side, right? So if I want to find the hypotenuse, what do I do to the short side? That's right. No, it's twice. It's not. Well, we will in a second. We'll do that in a second. You could do this now if you wanted to. You're right. I know what you're saying now. Right, you could do that now, but we're going to wait till the end to do it. All right, either way, it's fine. So what I have to do is take this, multiply it by 2. Take this, multiply it by 2 to get this. So watch the math. Multiplying by 2 is not hard. 14 over the square root of 3. Now what David was saying was this. You can't keep it like this. This is not simplified. Somebody besides Joe and David, tell me why this is not simplified. Besides Joe and David. Because I know. Can't have a square root on the bottom. Thank you, Connor. You cannot have the square root on the bottom. So you multiply the bottom by square root of 3 and top by square root of 3. We've done that plenty of times before. It's not like I did it one time and I kind of just snuck it in there. We've done this many times. All right? Would you agree with that? Yeah. 14 square root of 3 over 3. But if your head's down and you're sleeping, then you don't realize that I do this stuff in class in front of you. All right? That's why I try to get you not to have your head down and not sleep, because you're missing important stuff. So that is your answer for x right there. That's the only acceptable answer on that problem. It's the only thing I would have accepted because it's simplified and it's exact. All right? This is the same number as this. If you put both of those in the calculator, you get the same exact thing. But it's not simplified. And look at the instructions. The instructions say it needs to be a simplified answer. Okay, enough of that. If you need more help on that, just go back on YouTube. You can pause it, you can rewind, watch it 2 or 3 times to make sure if I said something maybe a little too quickly or something like that. All right, let's do another one. Another right triangle. This is another one of those 5-second problems. It takes me longer to draw the thing out than it does to actually solve it. And again, there's really no arithmetic involved in this at all. A, B, C. All right, this is number 14 and 15 on the test. So watch. Number 14 says find the sine of the angle. It doesn't even ask you to find the angle itself. I made it even easier. It just says find the sine of the angle. So look, let's find angle A. It's this one right here. So you got to know your trig functions, though. Again, like I said earlier, there are things that you have to know. Even though you can do this in 5 seconds, you got to know some stuff before you actually start doing it. So what's the little mnemonic device that we learned? SOHCAHTOA. All right, let's jot that down. Did anybody write that on their test at one point? Okay, that's a good idea. You might have it memorized, but it might be a good idea if you're new to this stuff to write that down on your test so that you remember. Now look, which one's the sine? It's this one. Opposite over hypotenuse. So here's your angle. Which side is opposite angle A? 12. Which side is hypotenuse? It's 15. Now, you could leave it like that. I didn't say to simplify it. You could leave it like that. But it's always better to simplify your fractions. So 3 goes into both of those, right? And that's 4 over 5. I would accept either one of those. Now, what if you would have put that into your calculator? You would have gotten like 0.8. Not like 0.8. You would have gotten exactly 0.8 in your calculator. Would that be an acceptable answer? Why not? It's equal to 4/5. Because it's a decimal, right? And the question says write it as a fraction. That right there is not a fraction. These two are fractions. So this is the acceptable answer. Make sense? You got to follow instructions. Tell you what, you learn how to follow instructions now, that's going to get you through life. I mean, because that's what life's all about. It's just following instructions from other people. Okay? That's just, get used to it. No matter if you're the biggest boss that there is, you still have to learn how to follow some instructions. Okay? Number 15, same kind of deal. The tangent of C. Now look how easy this is. You look at C and you say tangent. Which one's tangent? Opposite over adjacent. So which one is opposite? 9 over adjacent, which is 12. That's it. That's all you had to do. Except it would be nice if you simplified it. If you wrote it like that and circled it, I gave you credit for it. Okay, didn't mark any points off for it. That would be 3 over 4 if you reduce it. Okay, no decimal on this. It would be 0.75 if it was a decimal, but I don't accept that because it asks you to write it as a fraction. It's easy enough, isn't it? Have we done anything real difficult yet?
No.
I don't think so. All right, now there are some things you had to know though. You had to memorize some things. All right? It's not hard to do these things if you have some of this stuff memorized. Like this right here, that has to be memorized. All right? This stuff right here, that's got to be memorized. And that's just a matter of you sitting down and taking the time to make sure that you memorize those things. That's what it takes. It just takes time, and it takes just a little bit of effort. Okay, let's do a couple trig problems here. Right triangle problems. So when you have a right triangle, first thing I think about when I see a right triangle is either Pythagorean theorem or a trig function. All right, so let's take a look. This time, this is not a special triangle. This is not 30, 60, 90. It's not 45, 45, 90. Some crazy angle, 37 degrees. Here's what they give you right here. This is number 16 on the test. All right, so I want to find what x is. That's what I'm trying to solve for. Well, just like we did before when it said the sine of angle A or the tangent of angle C, look at the angle. This is our angle right here, 37. Now, how do I know which one to use? Do I use the sine? Do I use the cosine? Do I use the tangent? Look to see. Right, it's SOHCAHTOA again. If you want to, we can jot that down one more time. All right, look at the two sides that they give us. Jake, head up, please. Yep, they give us the opposite side and they give us the adjacent side. Which one of these three is opposite and adjacent? It's the tangent. Okay, so you take the tangent of 37 degrees equals opposite over adjacent, right, which is x over 7. That's how you set it up. One little thing to solve for x. X is already on top, so I multiply both sides by 7. It'll cancel here. Multiply that side by 7. And then you just chuck that in your calculator. And let's see. I don't have the calculator ready. I'll just give you the answer. It's about 5.3. Some people wrote just 5. Look at the instructions again. And I actually gave it to you. I was a little bit wimpy on this. Okay, I should be a lot tougher. If I say round to the nearest tenth and you don't round to the nearest tenth, what should I have to do? I should mark it off, shouldn't I? Okay? But out of the kindness of my heart, I let that go because I figured, well, this is really what I'm testing. I'm really testing to see if you can do this. So if they didn't round it, okay, whatever. But it still ticks me off a little bit because the problem says right up top, it's in bold and everything, it says round to the nearest tenth. So it needs to be 5.3. Everybody with me on this? I have one kid in my other class. He just loves all those decimals on his calculator. No matter what it says to round to, he's always taking it out like 8 decimal places. I don't know why. That's more writing than you need to do, right? To me, that's just a waste of time. I don't know. Is that just me or not? You wouldn't want to do that, would you? Nah, I wouldn't do that. I mean, if I told you to write out 8 places, you probably wouldn't do it. But some people do it, even when they don't have to. I don't know why. But I guess it's just a thing of theirs. So let's do another one of these. This time, they don't tell you the angle. They actually ask you to find that angle right there. And this is 10, and this is 4. Okay, so this is what they give you. And you have to find what x is. Now, this is not a 30, 60, 90. It's not a special triangle or anything like that. So you got to look to see which trig function you're using. Here's your angle. Look at these two sides. What is this side 4 right here to this angle? It's adjacent. What is the 10? Which one uses adjacent and hypotenuse up here? The cosine. So that's what we use. The cosine of what angle? X, because that's the one we're looking at, right? Cosine of x. This is Joe's last day in here, so he's getting all the answers in while he can. Good, I appreciate it. So the cosine is adjacent over hypotenuse, and it's 4 over 10. You don't even have to reduce it or anything. We've talked about this a bunch of times. For some people, it gets a little bit tricky, but I think we've said it so many times that it should be straight to you. But apparently it's not, because a lot of people miss this problem right here. So we don't divide by cosine, do we? We take, say, Joe, what is it? The inverse of the cosine. That's how we write the inverse of the cosine. All right? And we stick that into a calculator. We've talked enough. I've talked way enough about how to put stuff into a calculator. So I'm not going to do that today. You need to figure that out on your own. And so number 17 came out to 66 degrees. Why didn't I put a decimal? Why didn't I put 66 point whatever? That's right, because the problem says, if you look in the instructions, it says when it's an angle, round it to the nearest degree. Not decimal, not tenth. Okay, just to the nearest degree. Again, I had people putting, I forget what it was. I don't know if it rounded to 66 or was 66 point something, but I had people put like 66.1 or 59.8 or something like that. No decimals. It says round to the nearest degree, which means no decimals. All right, so that's all you had to do right there. All right, we're almost done. See, we're getting there. Now, 18 and 19, a little, I don't know if they're tougher or not. But it's not a right triangle this time, though. Alright, so there's your triangle. It's not a right triangle. So we can't use the regular trig functions like we were using earlier. We can't just use sine, cosine, tangent. We can't do Pythagorean theorem. Alright, we can't do all that stuff that we do for right triangles. So we have two methods, don't we? Law of sines and law of cosines. So you got to figure out which one of those do I want to use. Here's the way that I like to look at law of sines the best. Look at the angle and see if it has a side opposite. Do I have an angle and a side opposite each other? Yes, I do. And then I have this angle and I got this side, which I don't know, but they're opposite each other. That's a perfect classic example of using the law of sines. All right, so let's use the law of sines. Now, what am I trying to solve for? So this is my personal preference. Talked about this in the other class, and they're like, oh, I thought you always had to do it like that. That's the only way you can do it. No, this is my personal preference, is when I'm solving for x, I put that on the top. I think it's easier to put that on the top. So let's set it up. It's going to be x over what's opposite. That's right, it's 80, so it's the sine of 80. It just works a lot easier if x is on the top. And then if I put the side on the top, I take these two. What do I put on top with these two? The 12. Right, and then I put the sine of 40 down here. Right? It's not too bad, is it? Law of sines isn't so bad. It's not very scary. So look, I got to get x by itself. I have to get rid of the sine of 80. So we've done this a bunch of times. I get rid of that by multiplying by the sine of 80. So I do the same thing to the other side. Watch what we do when we multiply this by the sine of 80. I just put it on top. Put it right after that 12. That's being multiplied by the sine of 80. We've done this a bunch of times. You can go back and look to see where we did it. I'm just giving the answer right now. This is number 18. You get 18.4. Okay, and that would be the answer when you plug it into a calculator. What you need to do, if you've been missing these problems, then you need to write this down, try it yourself, whether you do it now or you do it later. At some point, you need to be able to take this and put it into a calculator and get this answer. All right, let's do number 19 now. 19. We're getting close. Plenty of time to spare. Plenty of time to give you a homework assignment, right? Nah, I'm only kidding. Joe did because he's not going to be back, so he doesn't care. All right, here we go. This is what they give you. 103. It's 13. That's 20. And that's x. All right, look at this. A lot of people love the law of the law of sines. Okay, and they're like, oh, I'm using the law of sines no matter what. But could you even use law of sines on this even if you wanted to? No, because look, here's your angle, right? Look, you don't know this side. That means I must know another angle and side combination. Do I have another angle side combination? No, I don't. All right, I don't know this angle, but I do know this side, but I don't know the angle opposite. I know this side, but I don't know the angle opposite that. Okay, so I don't know any of those combinations, so I can't use the law of sines. So I'm going to use the law of cosines. Law of cosines is easy to see if it's side, angle, side, or you could have side, side, side. All right. That's what we have. So we use the law of cosines. Basically, this is just plug and chug. There's really no algebra involved in this particular problem at all. Just plug stuff into a formula, put it in a calculator, bang, you're done. The thing is, you got to know the formula though, don't you? All right? If you don't know the formula, you're sunk. So what's the formula? Yeah. In this case, our c is our x though, isn't it? All right, so let's use the numbers that are here. So x squared equals 13 squared plus 20 squared. That's kind of like Pythagorean theorem, isn't it? But then we got a little extra stuff added to the end. Minus 2, right, times these two multiplied together, right? So 13 times 20 times the cosine of the angle that's opposite this side, which in this case is 103. Got it? And this is just all a matter of throwing into your calculator. You guys love your calculators. You want to use them all the time, right? Well, this is a chance to use your calculator. Now, there's one key thing that I always point out to this. Well, parentheses right here and right here. I think it's very important that you put the parentheses there yourself. It helps organize things much better. So you can put this all in one shot in your calculator. 13 squared plus 20 squared minus parentheses 2 times 13 times 20 cosine of 103, close the parentheses, but that's not my answer. If I hit equals, that's not my answer. That just gives me all this stuff. That's right. If I want to get x by itself, I got to square root. So I hit square root, and once you hit square root, you should get 26.2. Okay? What's that? Oh, this thing right here? What, this little swooshy thing?
You said you always say it's all that practice.
It is practice. I used to practice doing these things. I was such a dork. All right, so when I first started teaching, I was doing these, and mine were terrible. They were just awful because I was trying to go too fast, but I go a little slower. This one's not that great, but yeah, I used to practice those. Like if I went this way, like that. That's kind of cool. It looks like Alfred Hitchcock's thing. Nobody even knows Alfred. Anybody know Alfred Hitchcock? He was not the president. He was not our president. He was British anyway.
Is he still alive?
No, he's been dead for a while. Yeah.
Because they always show his movies on TV.
Yeah, he's got great movies, and he's got these half-hour TV shows too that they'll show at late at night or something. Yeah, I used to watch it all the time. They used to show his half-hour shows like 11 o'clock every night, so I'd watch it before I went to bed.
Yeah.
They're really interesting. You could probably watch them on Hulu or something like that.
Like TV station chill.
Yeah.
Chilling.
Well, they're kind of sometimes they're scary. Sometimes they just make you think. Sometimes they're
all, like, horrible.
yeah, they're kind of like odd, kind of, but they're really interesting. They always have like a twist ending at the end. I always love movies like that where you think you know what's going to happen, but they completely change it around. It's pretty neat. All right, let's look at number 20. This is our last one. Okay, then we'll stop. All right, here we go. If you notice, did you notice that number 20 was just like the one that we did the day before, except instead of putting cell phone tower, I put flagpole? But I actually kind of messed up a little bit. I know. I messed up a little bit, and I put the word tower in there because when I was typing up the test question, I was reading from the book, but I was like, well, instead of putting the girl's name, I'd change the name, I changed the flagpole, I changed the numbers, but I was still had it in front of me. And so I saw tower, and I accidentally wrote tower instead of flagpole. So that's why it says tower in there. But that's what it means. But watch how we do this. Look, here's a flagpole. So what's a flagpole look like? It's just straight up and down, right? It's perpendicular to the what? To the ground. Now this girl, she starts here, Jen, she starts here, and she starts walking about, what did I say, 70? Yep, 70 feet away. But then she walks far enough when she looks back up at the flagpole, she's looking up at a 53-degree angle. That's your picture right there. You don't have to have a fancy flag or anything like that, or even draw a picture of the girl. That's really all you need. So look, this is the flagpole. This is the ground. She walks 70 feet. So from here to here is the 70. I had some people making this the 70. I had some people making this the 70. She's walking along the ground. She's not walking some imaginary line from the top of the flagpole down to here, okay? And she didn't climb up the flagpole and scoot down either, okay? She walked across away from the flagpole, okay? That makes sense, doesn't it? Which one's the flagpole?
That one.
This one, the up and down one. That's what we're trying to find. We're trying to find out how tall the flagpole is, all right? So we have X right there for the flagpole. I had people solving for this side right here. That's not the flagpole. Okay, this one right here is the flagpole. Now she looks up at an angle of elevation of what? 53 degrees. And there it is. There's your picture. That wasn't that hard. I can't believe how many people didn't even try to do this. I had people that didn't even write down a picture. I know, I'm not saying everybody. Yeah, that's definitely. I'm not saying everybody didn't try, but there's too many people. Even on the corrections, listen. Even on the corrections, I had people not even try this. Did anybody look at this and say, oh, this is pretty much like the one we did the day before? Anybody do that? Okay, yeah.
But I still got it wrong.
You still got it wrong? Okay.
I remembered it though.
All right, well, that's good. At least you remember it. But watch this. How do we solve for x? Opposite over adjacent, which is tangent. You're right. So the tangent of the angle is the opposite over the adjacent. Look how easy the math is here. Multiply by 70, plug it into a calculator, and you get 92.9. Well, it is easy. I don't make it easy. Look, I don't make it easy. There's nothing special that I'm doing to make it easy. It just is easy. You just have to know. No, you don't have to square root. There's no squared in here. Yeah, there's no square. Where do you get square root? Nothing's being squared. No, there's nothing being squared, so you don't. Okay, you square rooted this because it says x squared is equal to all that, right? This one right here, no square roots on that. No squares, no square roots. And that's it. That's your test. Now look, that's the last time that I review for this particular test. All right, it's on YouTube. It's being recorded. I'll put it on YouTube, put it under your class. Now remember the one we watched yesterday? That's under 6th period as well. If you go to your YouTube page, it's under 6th period as well. All right, even though I taught it 4th period. Okay, but it's still on there. So you have now 1 through 20 from this Chapter 8 test all on YouTube. So when it's time to take the final, whenever you have to take the final, make sure you go over this again so that you know how to do every one of these problems. Because you're going to see problems. Listen, I promise you, there will be some problems on the final that are exactly like the problems on the test that we've had. Okay? Some, the numbers will be different and stuff, but some will be exactly number for number, word for word. All right? So it's to your benefit to go to the YouTube, watch them again. All right? I would have a pencil and paper, pen, whatever, right in front of me. Okay? You see the problem? Try it. Give it a shot without looking at the answer. See if you can get it. Watch the YouTube video to see if I solve it like you do. Okay, that's the best way to do it. Take advantage of this. Some of you guys are just not taking advantage of using these YouTube videos, and to me, that's just crazy. That's just crazy talk. All right, you got to use what I've given you. I've given you a lot of tools to be able to get these problems right. And I think the ones that got really, really poor grades is because you didn't take advantage of the tools that I've given you. All right, the ones that are doing well in here are taking advantage of it. And that's all I got to say about that. Okay, that's it. Have a good weekend. No homework tonight.